Okay, so hello and welcome to this video tutorial for E411, Statics and Dynamics of Simple Mechanisms. So we have this problem here, and I'm just going to go through it, and a lot of the ideas and concepts that I'm going to use, I'm going to trust that you're already familiar and somewhat comfortable with. So let's have a look at this problem then. It's asking determine the magnitude of the resultant force and its direction measured clockwise from the positive x-axis. What do we mean by the resultant force? Well, the resultant force, we're just talking about the sum of all the forces acting on something, right? And we're being asked to determine its magnitude and its direction. And as you guys probably know, so we're taking the sum of these forces in the diagram here, this 400 Newton force and this 800 Newton force. As you guys may probably already know, adding vector quantities together is not as simple as adding numbers together. If we're wanting to add vector quantities together, oftentimes we have to break them down into components. So what we might do in this instance is break these forces down into their vertical and horizontal components. Let's go through this force by force then. So we've got this 400 Newton force acting 30 degrees to the horizontal. We could say then that its horizontal component looks like this, and that its vertical component looks like this. Let's put the 30 degrees in there, why not? The magnitude of its horizontal component we can describe as 400 cos 30, and its vertical component as 400 sine 30. If you're unfamiliar with what I'm doing here, I would suggest refreshing your understanding of vector quantities. We've got this, I apologize for my awful handwriting, this 800 Newton force here. Its horizontal component might look like this, so that would be 800 cos 45. We can assume that this angle with the horizontal is 45, since the angle with the vertical is 45. And its vertical is 800 sine 45. Okay, so like the question asks, we're wanting to find the resultant force here, which is simply the sum of the two different forces, and we would add them together according to their components. So we would sum the horizontal components together. That would just be 400 cos 30 plus 800 cos 45. And okay, the vertical, that would be 400 sine 30 minus 800 sine 45. If you're wondering why I'm subtracting the sine 45, the reason I'm subtracting the sine 45 is because the vertical component of this 800 Newton force is acting down, right? And since it's acting down, that's what we typically take as the negative direction in the vertical. Okay, so we subtract the vertical component here, and that leaves us with, put this in my calculator earlier, this is equal to 912.1, and this is equal to minus 365.7. Okay, wonderful. So let's just drag the screen down a little bit here. We have our horizontal and vertical components of our resultant force. So let's diagrammatize the resultant force. don't have to do this, but I'm going to do it anyway. So that's not going to do it for that one. So we understand that the horizontal component of this resultant force is 912.1, and that its vertical component is 365.7. Now, to determine the magnitude of this vector here, this might already look pretty self-explanatory to many of you. This is a simple Pythagoras theorem problem. Okay, so if I wanted to find the magnitude here, please go away, email. That would just be the square root of 912.1 squared plus 365.7 squared. If you're unfamiliar with how we got this, I'd suggest refreshing your understanding of Pythagoras' theorem. And we find that to be... I didn't write it down. Let me calculate it here. It's the square root of 912.1 squared plus 365.7 squared, which is 982.7. 982.7. Let's put the unit there and just underline it because that's one of the answers to the problem. The problem also asked, let's remind ourselves of the problem. The problem asked for the magnitude, it also asked for its direction, right? So how might we determine its direction? Well, by inspection, this is nothing but a simple trigonometry problem. I'm trying to find this angle here, right? The angle with the horizontal. How I might find that? Well, I've got all three sides to this triangle, right? I've got 912.1 is the adjacent, 365.7 is the opposite, and I've just calculated there that 982.7 is the hypotenuse. I'm gonna use tan. Tan is what you would typically use, and I'll explain that here. So tan of theta is equal to the opposite of the adjacent, and in this instance, or in a lot of instances, the opposite can be described as the vertical component, and the adjacent can be described as the horizontal component. So the fact that we're using tan here means we're omitting the hypotenuse, and that's relevant because, well, we needed to determine the hypotenuse using Pythagoras earlier, but we could have chosen to do this. We could have chosen to use tan even without having calculated the magnitude, right? Which can be helpful in some instances. So that's why you might typically use tan. Okay, so tan of theta is equal to the opposite of the adjacent. If I take the inverse tan of both sides here, I find that theta is equal to the inverse tan of the opposite over the adjacent. You know what? I don't need to rewrite opposite over adjacent. I'm just going to write the numbers in. So the opposite in this instance is 365.7, and the adjacent is 912.1. Let's bung that in our calculator. .365.7 over 112.1. That's 21.8. 21.8 degrees. Awesome. And let's just underline that as well. Wonderful. So this is the answer to our problem. The magnitude of the resultant force is 982.7 newtons, and the angle with the horizontal, moving clockwise from the horizontal as the question posed, is 21.8 degrees. Thank you very much for watching, and if you have any questions, feel free to leave them in the comment section.